So thanks to everyone for joining the introduction to TinyML session. So we are ready to start and yep. And yeah, I hope you can see my presentation. So today is the one of its kind. We are doing the first TinyML workshop online. So there might be some issues. So please communicate with us. You can use the chat option. And if you want to speak, you can raise your hands. There's a button an icon of hand. So you can press that, then we will unmute you. Then you can speak. Or if you want to type your question, you can go to the chat or Q&A option. Okay, cool. So we'll starting. So first I want to introduce about Robu. Robu is your one-stop destination for electronics, mechanical, DIY, hobby, RC and engineering products. So Robu is a well-known partners in India. They actually sell different kind of electronics part, mechanical parts, DIY and etc. So check out their website, and all the things we are doing right now will be available at a Robu in a reasonable price. I'll share the link and everything in the later. Okay, cool. Another one is Seeedstudio. We're using Seeedstudio product today to make the TinyML, and Seeedstudio is the IoT hardware enabler, providing services that empower IoT developers to swiftly realize their products. Okay. Next, Makergram. Makergram is open maker community for hardware enthusiasts to grow further. So let's start. Myself, I'm Salman Faris. I'm one of the team member of Makergram. It's a maker community and part of Seeedstudio as a ranger and part of Edgimbles as an expert group. And I'm very much passionate about science and electronics, I hope. And I think most of you are also very much interested in electronics and DIY, these kind of stuffs. Yeah. So we actually share the same passion and interest. So like I mentioned, this is the first of its kind virtual workshop that we are doing. And previously we did some hands-on in-person workshop in different part of the area. And this is the first of its kind. Okay, so you lucky to have you in the first batch. So yeah, so today we are going to use the Seeedstudio TinyML workshop course. So we will walk through what is TinyML and what we can do and how we can implement and how we can build your own projects, etc. So yeah, today agenda is basically introduction to AI, ML and DL, like deep learning, and then what is TinyML and the example of TinyML applications and how to build a voice controlled smart light. Also walk through on TinyML computer vision project, and at the end there will be a question and answer session. Okay, and also if you are not just I want to remind you again, if you can hear me properly or if you have any doubts, please ask your question on the Q&A part, or you can raise your hands. Okay, all good. So since I can see your face, I can read your emotions. I don't know if you understand it or not. So it's difficult. So please mark your question on the Q&A part. Cool. So we can get started. First of all, what is AI? What is ML and what is deep learning? I hope you might already hear this word many times, like AI, ML, deep learning, etc. So what are those and what are the difference between AI, ML and deep learning? So let me clarify for you. So artificial intelligence, actually that means, like its name implies, it's making intelligence artificially. It's like mimicking human intelligence. Humans are one of the top of kind intelligent beings in the animal kingdom. So we are actually mimicking humans to make it a machines. So that actually AI, we are actually mimicking. So I can give an example. I hope almost most of them already familiar with the movie Endiran, right? The movie Endiran. So there is a robot that can think like a human. So that is a AI, artificial intelligence application. So artificial intelligence basically mimicking the human intelligence. Okay. And what is machine learning? So machine learning is a technique to understand like pattern, recognition pattern, and learn from it and apply the patterns. So it's kind of a technology that we can learn from the patterns. Okay, so like the pattern can be like you have a smart watch, right? The watch can actually count your steps, or watch can track your activity, whether you are walking, whether you are running, etc. So that actually the ability to make read the patterns. Okay, so what is deep learning? So deep learning basically is an algorithms. So set of algorithms that help you to make machine learning. Okay. There are different kind of algorithm. Today we are going to see some of the algorithms. Okay. So deep learning is kind of set of algorithms that actually extract the features and it help machine learning model to create. With the machine learning models, we can actually make artificial intelligence. Okay, so currently human race is actually trying to build artificial intelligence. It's like trying to make robots that similar to humans. Okay, we are not yet there, but we are still trying there. But you know, there is a mainly two part: artificial general intelligence, artificial narrow intelligence. The general intelligence is where we are actually mimicking human intelligence same as like that, but we are not yet there. But actually we are in the artificial narrow intelligence. You might see the Google Home, like Amazon Alexa, etc, etc, etc. So yeah, now I hope you get an idea like what is AI, ML, deep learning. So AI is the application, ML is the technique, and deep learning is the algorithm. Okay, so today we are focusing on the machine learning, the technique that recognize the patterns. Okay, cool. And if you have questions, I want to repeat again. If you have a questions, please share it on the Q&A and we will take a look at the later. Or if you have an immediate question, you can raise your hands. We will unmute you, then you can speak. Okay. Okay, cool. So like I want to show like I think most of them you already familiar with the programming, right? So you might think what is the difference between the programming and machine learning? So what's the different? Okay, I want to inform you, like I want to let you know that in programming we first create an algorithm. Okay, suppose we have a problem. Okay, for a problem we first create an algorithm. Then algorithm we actually put input, then the algorithm will be running inside a computer, then it will process it and we will get an output. Okay, suppose we have a problem like we need to make sure that a number is odd or even. Okay, we need to check a number is odd or even. The algorithm for that application is we actually try to see if there is any remainder after we divided by 2 or something like that. We'll check if there is some divider, like remainder. Okay, so this is a small algorithm. So input, algorithm, and output. So the algorithm is made by us. Okay, the input can be user provided input, and the output will be the, if it's depends on what kind of algorithm we use. Okay, this is a traditional programming. Okay, so what is about like machine learning? So machine learning is about, there is actually mainly two part. Okay, in program there is only there's a two part, but one is basically we are creating the algorithm. Second one is we are using the computer program to run algorithm. In machine learning we have a two part. One is called training machine learning model, train machine learning or creating the model. That's the first part. Okay, and second one is inferencing the machine learning model. Okay, the first part is what we do is we are actually collecting input, and we are actually that's also called data set. We are collecting the data set and we are also collecting expected output. Okay, then giving to the computer. Okay, then computer will create algorithm. Okay, that algorithm we can use later. Okay, so instead of we are making algorithm, we are actually giving input and expected output. Then computer will be giving the algorithm. With the algorithm, we are actually inferencing. So inferencing means similar to what we did in the traditional computer program second part. Like there will be an input from the user input, and there will be the trained model. The trained model will be the algorithm. Okay, and there will be a result. Here result will be as in a conference or probability. Okay, so this is how the difference between the machine learning and traditional programming. I hope you get an idea, right? So like this like input algorithm and we will get an output, but here we actually giving input and expected output, then we'll get an algorithm. The computer will be generate an algorithm. From the algorithm we can use everywhere, like we can use in different thing. So the creating algorithm is called machine learning training part. Okay, training part. And running the algorithm we call inferencing. So these are the key terms we need to understand in the following sessions. Okay, so let me see if anything comes on the chat. Not yet. Nothing in the Q&A, but let me open the chat and see if anything we get. What are the languages to learn making AI? So I think Srivatsava asking a question. What are the languages to learn for making AI? So we will take a look into the later slides. So I hope we can answer that on the coming slides. Okay. Okay, cool. The next one is like I want to let you know that machine learning is human learning. So this is a key concept. So here we understand about the data set, because the data we collected and the expected output, that also called data labeling, and we creating the algorithm. Okay, here we need to see machine learning is human learning. Okay, when you're working with machine learning, consider machines as a newborn baby. Okay, machine know nothing. We need to give the instructions. We need to give everything. We need to give the knowledge, everything to the computer. Computer does not know anything. Okay, they just consider as a like a newborn baby. Okay, suppose like if you have a newborn baby and we want to teach him or like her about a dog or cat, how we do that? Okay, we will showcase some of the dog photos, right? And we mention, okay, this is a dog and this is a cat, this is a dog, this is a cat. This is how we teach a kid about cat and dog, right? Similar way, like, and when we are doing that, what happens is the kid's brain is, in the kid's brain there is something called neurons. Okay, small cells. Okay, small energy cells. So that actually will be developed. What happens is like the kid will brain will capture the images and try to see what are the difference. Oh, the kid might think, okay, the cat is a small one, the dog is a big one. Like that's how actually kid develop his brain. So that's what we understand from the research and everything. Okay, and later stage, the thing is actually stored in the brain. Okay, later stage, kid use the knowledge that's in the brain, and whenever he or she saw the dog or cat, like she or he, the kid can, baby can recall it's a dog or cat from the neurons it's saved on. Okay, this is about human learning. Okay, this is how human learn. Okay, so we will see something thing with our experience, with what we saw from our different kind of sensory organs like eye, touch, and feel, smell, different kind of things. We actually collecting the data and we are saving to the neuron, and the neuron will be compared with other things. That's actually very complex thing actually happening on the brain. Okay, that's not complete. We still now we don't know how exactly the brain works, but we know few things, like there is something called neurons, and that where we store our the small kind of chunk of memory, etc. Okay, this is how human learns. Same way, when we do machine learning, just replace the baby into the computer. Okay, computer means a device that can do calculation, that's all, right? So here we are using a different kind of computer. I'll show you in that. So here you can see we want to show a computer into to differentiate a dog and cat. So what first we need to do is we need to showcase so many dog and cat images. Okay, then mention that this is a dog, this is a cat, this is a dog, this is a cat. We need to do that. Then inside the computer, it's create an artificial neural network similar to what we did in the baby brain. baby brain, it actually will create. Okay, it's already there. That's what we actually have. So we are actually mimicking the human brain, and we are creating the neural network in artificially. So it's called ANN, artificial neural network. So we actually extracting the features. Okay, the computer will extract the features, like in the picture you can see, like the cat tail is kind of a curly, so that can be saved in the neural network. Or I can say like the cat ears looks like a pointy kind of thing, I can say. And I can say the dog is a big one. This kind of information will be stored on artificial neural network. Okay, this part is called training, machine learning training. So we call this a training. So another part is inferencing. So this experience is saved on the neural network. The same neural network can be used in to differentiate if it's a dog or it's a cat. Okay, I hope you got the idea, right? So if you have any question, you can post it on the chats or QA. Okay, cool. So yeah, I hope you got an idea, but because this is very important, so we are going to the from the fundamentals, because I want to everyone on the same page before starting the uh, if it's like the fundamentals of ML, deep learning, and AI. So now I hope you got an understanding about what is the difference between ML and traditional programming, and also what is the difference between the machine learning and human learning. So this is how machines are learned. Okay, that's how the humans also learn. We actually mimicking human learning to the machines to do the machine learning. Okay, cool. So yeah, next slide. Okay, in the past actually we did machine learning in the cloud. So that means cloud means a powerful computer that connected to internet. That's all about the cloud. Okay, so in the past we did all the machine learning in the cloud. So it would take, the cloud means it's a big machine, and the models means the neural network will be like 60 to 32 GB, and the speed will be teraflops of speed. And our main thing is will be focused on accuracy, and we need a hardware like a GPU, graphic processing unit, and we need device like TPU, tensor processing unit, and we need big specific FPGAs are like specific high power devices. And there is some models like, we need so many stuffs actually in the cloud. So what happening here is, here inside in the, this is actually the baby is actually saving the knowledge in the neurons in the baby's brain. Here the computer is store the data in the computer hard disk, but the computer will be connected to the cloud and it will be in the different place. That actually the cloud ML, cloud machine learning. Okay, so after that, we went to the mobile machine learning. The mobile machine learning means the machine learning can be run in mobile phone. So I hope you might use Google Photos, right? The Google Photos, what happen is, like, you can see if you go to the people section, you can see it automatically identify the different peoples. Okay, right? So different peoples you can see. So that actually using the machine learning. And you can see, like, if you're using okay Google, if you say go okay Google in your Android phone, it actually wake the Google Assistant, and actually it will ready to take your command. Same for iOS. If you say hey Siri, it will take your command, right? So that actually mobile machine learning. So that means machine learning that's run on cloud, machine learning running on mobile phone. The next one is the new era, the machine learning running on microcontrollers. That is tiny machine learning. Okay, so we can actually run machine learning models on less than 100 KB of RAM. So that's a sweet spot that we are working today. And we can use different kind of sensors like CMOS sensors, IR, cameras, audio, and IMU, temperature, etc. Okay, so that's today we are going to discuss. Okay, so like in the past, IoT 2.0, that's all about Internet of Things, things that connected to internet. We collecting the data, sending data to the cloud. Okay, we are all sending the data to the cloud. The devices will be a streaming devices only. But the next thing is actually intelligent on things. Intelligent on things means we don't need to send the data to the cloud. Instead, we can process the data in the device itself. So here you can see there is a toothbrush. Okay, so it's a smart toothbrush. So what it can do is it can detect your like brushing pattern, and you can suggest a better patterns that you clean your mouth more better. Okay, that different uh, things. You can see there's an Apple Watch here. Apple Watch can track your step, sleep, etc. Recently, there are some news like Apple Watch actually helped a like cardiac arrest patient to prevent its getting heart attack. It's giving it actually continuously monitor the ECG of the person and actually is sending signals to the patient or the caretaker. So we are focusing on the intelligent on things instead of the Internet of Things. Okay, device can make its own decision, etc. from the patterns. Okay, so you can see the beauty of the intelligence of things: bandwidth, reliability, latency, privacy, and energy. Because it's small microcontroller device, it can actually work on few more days, like 20-30 days to years in a single cell battery. Okay, anyway, we'll look into the later. I just want to give the intelligent of things protocol things. Okay, so again we are coming to what is TinyML, machine learning. So we get to know about cloud machine learning. Cloud machine learning is the machine learning that runs on the cloud, and mobile ML is the machine learning running on mobile. So the tiny machine learning is the field of intersection of embedded systems and machine learning. Okay, that means we have machine learning, very powerful technology here. We have embedded system here which can do a lot of stuff in a single cell battery, and it's very power efficient in the small in size and compact. So we are combining this both to make the tiny machine learning. Okay, we are, and there will be some like limitations also, but today we are focusing on what are the application and where we can use the TinyML. Yeah, so you can see I know like some of you, few of you already you are a students and everything. So I want to give an perspective where you can lead the TinyML to the future, future proof. So it's a fastest growing field of machine learning, the TinyML, and it use algorithm, hardware, software. It's a combination of hardware, software, and like algorithms, etc. And it actually use on device sensor analytics. So suppose if you have a device here, it can do the processing inside the small devices. The machine learning can be run in the single devices, and it's very low power consumption. So that's the beauty of the embedded systems, right? That's why it's also called a tiny. And like it always on ML, we don't need to sleep sometime and gather data then sleep. It always on because it only use low power consumption. And you know, it's battery operated. We don't need to plug into like a 240 AC, or we don't need to use a big GPU or kind of thing. We can run it with a small coin cell battery to a lipo battery. Okay, so like what are the benefits of edge ML? Sorry, what are the benefits of edge ML? So one is the innovation. We can actually we can use different features to in your existing technology. And second one is very important one is privacy. You know, like in the cloud ML, we need to send all our data to the cloud, and that will be processed then send back to here. Suppose you are actually measuring your sleep quality. Okay, you are wearing your band, so you need to send all your sleep data to the cloud. So that's very difficult, right? If the server is compromised, all your data is gone. Okay, so that's why we focus on the TinyML or the edge ML. Main focus is about privacy. You don't need to send your data to the cloud. You can process all your data to the small devices like these one. Okay, and the power, like absolutely we discussed it in the latest slide, because when we since we are you working with the microcontrollers, we need the less power. And the cost also, since we are working with the small devices like this one, the cost is very less. Reliability, because we don't need to have any we don't need to have any network connection to make decisions, so it's very reliable compared to the cloud ML. Latency also, like we don't need to send the data back and forth between the cloud to make decisions. Okay, yeah. So don't worry, we will go to the answer section. First, I want to cover a few of the theoretical part. That's why I'm going to do right now. Okay, so these are the few examples that we know today, like the Hey Siri, Okay Google, Hey Alexa, these kind of Amber application in your watch or your like on your mobile phones, this kind of devices. And you can see the Apple Watch is the best example for that. And there was a like a shoe developed by Adidas, a football boot specifically. So what it can do is it can actually measure, it can actually like find how many like kicks the player made, how many like penalty kicking, and how many passes a particular player actually did, and how many dribbling the player need. These are very crucial to, so that the coaches can focus on their like the coaches can focus on their like the training, and they can increase the reliability. So this it's actually a product that based on tiny machine learning. So you got a question like what is the difference between intelligence on things and internet of things? Okay, that's a good question. So internet of things is basically actually we are actually sending the data only. Like if it's a if it's a what we call, if it's a smart watch, it's actually sending the data to the cloud without analyzing the data. Okay, but intelligent device means it's actually processing the data itself in the like in the watch itself and doing the decision from there. Okay, so that's the main difference. We are going to make a small intelligent product lively. Okay, I hope you I got solved the question. Got that. Okay, good. So this is where actually we stuck, right? I actually give an example of Adidas smart boots, so it can monitor the like player kicking, penalty kicking, passing, dribbling, etc. So they can make a decision later. So it's all done in the shoe itself. So there is another example is called Elephant Edge. It's a this was a popular project done by different kind of like NGOs. So it's Elephant Edge, elephant monitoring device. It's actually in the wild. So it's actually is working, and you can know with this one we can actually monitor the elephant movement. We can see if the elephant is moving to the like the people area where people lives, and we can also monitor if like the elephant is moving to farmers or is trying to make the damage the crops, etc., using computer vision, using like accelerometer, gyroscope, etc. So anyway, we are looking to the latest slide how we can do that. Okay, so like TinyML is all about sensors, data intelligence. Okay, there are so many sensor actually in the IoT, like Internet of Things, so many kind of sensors, but the data is not being used. Okay, suppose if we have a sensor inside in my chair, we can make decisions like how many times I am sitting in the chair, in what position I am sitting. So from that I can make some kind of decisions, right? Same to that. So I want to showcase different kind of sensors. Like there is something called motion sensors, like a gyroscope, like radar, magnetometer, accelerometer, etc. So I think all of your mobile phone have accelerometer. That's why when you are slipping the phone, it automatically tilt, right? That because your phone have a gyroscope and accelerometer. So it measure the accelerometer and the gyroscoping where the phone is in the space. And there are some acoustic sensors like ultrasonic, microphones, and vibrometer, etc. And there are a lot of environmental sensors like temperature, humidity, and pressure, IR, etc. Yeah, there are so many things actually outside. So we can use these sensors data to make intelligent applications. Okay. And you can see TinyML is already in the news. You can see like it's already in the hype. Like TinyML is actually going to be the next big thing. Okay. So yeah, this is actually the total machine learning paradigm you can see here. So here you can see from the cloud, it's actually if suppose if you have a like a live video stream analytics, okay, we need to stream a video, then you can you can't done it on a TinyML. You need to use cloud ML or other kind of more powerful devices. But here we are actually only focusing on ultra low power device and sensors, small smart watches that actually run up to 20 to 30 days or 1 to 2 years in a single cell battery. Okay, that's we are focusing on. You can see the only this part, the TinyML part. Okay. So we can do so many solutions like voice commands, health predictions, activity detection, gesture recognition, acoustic event, etc. So many kind of thing. And spaces, we can do so many stuffs. Suppose I'm in a room, okay? Every room we might have some kind of a light or some kind of air conditioning system. Suppose when we are reaching the room, we need to turn on the AC manually, and depends on how many people are occupied in the room. We need to control the air condition, AC, temperature, etc. So suppose think like if you have a smart computer vision system where it can count how many people in the room, it can automatically adjust the temperature, right? So that actually the power of HML or tiny machine learning. And there are some other kind of use case so in the industry and logistics, etc. Cool. Okay, so this is all about TinyML. Now you might have a question, what we can do with the TinyML and how I can make my own project with the tiny machine learning, where I can start with my project, etc. So that's why we had the webinar today to solve this kind of question, when we can start, when you can start the TinyML and where you can start, etc. Okay. So today we are actually working with a product called Seeedstudio Shao series. Okay, Seeedstudio Shao actually, Shao means tiny in Mandarin language or Chinese language. Okay, Shao means small kind of device similar to your Arduino, but in very small package. Okay, it's very small, and you can see this is a small device which comes with a camera module, also comes with an onboard microphone. You can see in my hand, very tiny, right? Very tiny and small. Okay, and there will be another models also. There are different kind of Xiao boards out there. There's another one without the camera. There is another one that comes with the ESP-C3, the RISC-V architecture. Another one is comes with the NR50 to 840, and another one is comes with RP2040, the Raspberry Pi 2040 chipset, and SAMD21. Different kind of board is actually available. So today we are focusing on the we are using the TinyML Xiao series boards, specifically Xiao ESP S3 Sense board. Okay, you can purchase the board from Robu.in, like only rupees 1499. Okay, so compared to like other boards is very cheap and very compact and very tiny. You can see here, when you purchase the board, you will get a main board, and you will get an add-on board, plus you get a camera add-on. So it comes with the onboard camera and onboard microphone also. Okay, so yeah, I'll share the product link in the comment later. So we are focusing on the Xiao series. Okay, so why we choose the Xiao is it's only cost less than 2000 rupees, and it comes with the camera and microphone on board. You don't need to purchase camera externally. Okay, so this is about a Xiao ESP30 to S3 Sense. It's only like 1499 at Robu.in. You can purchase from that's our partner. So yeah, you can see it's a bunch of GPIOs like analog pins, digital pins, and different kind of SPI I2C protocols also available. And it's also come with onboard like LiPo charger also. Okay, cool. So yeah, and another one, we have a SenseCraft tool. You can do machine learning model. So let's get started. I'll give you a demo how you can start. Okay. So this is the board I have here. You can see it's a small tiny devices. So what I need to do is I just want to plug it. That's all. It's a type C. It's already, you can see the light is turned on. So what I'm going to do is I'll open the tool called SenseCraft. Okay. Let's see. I can quickly make it TinyML model. I can run machine learning like the computer vision inside the device. I'll show you. So I'll just go and connect it. I'll choose my board. That's all. Then it's connected. Now I'm going to do face detection first. Let's see. Just click send. That's all. It automatically download the firmware inside. So if you want to a quick prototype, that's all. So let's wait a few minutes and it will do the flashing. And it's connecting again. Yep. Now we can see it's actually streaming live from my device, right? So we can see due to the light is very less here. That's why it's unable to detect me correctly. Let me give some light and see if you can detect my faces clearly. Yeah, here you can see you can now detect my face, and you can see 60 70 numbers, right? That is about like the confidence, how much how much uh, the device is confident about if it's a face or not. Okay, it's very cool, right? I just plug the device and like tada and click it, the machine learning is running on. So you don't need to very high power Raspberry Pi or high power other kind of devices to run the computer vision model. You can run with this like less than 2000 rupees this board. You can run computer vision inside this device. Cool, right? So you can actually try with a bunch of other models like a person classification, mask detection, emotion classification also. Let me show you that's also how to do emotion classification. So downloading the model and flashing the model. It will do all the job for us, the SenseCraft tool. Okay. Doing the flashing right now. Okay, connecting, that's good. So let's wait. Can see here, it actually selected as I'm happy right now. I'll give some light. You can see if I smile, let's say you can see if I am sad. Okay, selecting neutral. Say sad. Yeah. Yeah, perfect. It's working fine. So you can see when I am like smiling, it say it's a sad, it's a happy, and when I say like a sad face, it's a sad face. So it's a pretty cool, right? We can run everything on this kind of a small tiny devices. So that's about our first demo. I hope you enjoyed. Like I just plugged in the device and connected and clicked it here. So if you have any question, you can let me know, okay, in the comments or the Q&A part. Cool. Okay. Okay, the next one is like the next one is like I would like to show you like the KWS demo, keyword sporting. This is the one actually we are trying to do right now today.
Yes. No.
So when I say yes, the LED is turn on. When I say no, the LED turn off. That means like in traditional method, how it's working is like we need to send the voice to the cloud. We actually collecting the voice, send to the cloud, and then from there it process, then send back to here and turn on the light. Suppose if you have a network connectivity issue, the light will be not going to turn on. There will be no lighting or something like that. But here we are actually processing the machine learning inside the microcontroller, the Xiao ESP32S3 sense board. Okay, from here it's actually processing using the TinyML algorithm and everything. It's processing itself. Okay, we will see how we can made it. Before that, I see there are some questions here. Okay, we have questions like how you achieve custom object detection using this method. Okay, sure. Agash, we will actually see how we can make our custom machine learning models in the coming slides. Okay, cool. So this is the one we are actually trying to make. Okay, so how this is one we are actually for today we are focusing on the KWS, keyword spotting. The same method you can also use the image recognitions method also. Okay, so like we are actually taking the command and using the Xiao ESPS3. It actually check with the neural network and see if the voice contain a yes of the or the voice contain a no. If it's a yes, it actually turn on the LED inside with it, and if it's a if it's a no, then LED will be turned off. Okay, cool. So let's see how we can make one. And same for the images also. Okay, it use the camera to capture the image, and it compare with it to check with the neural network and see if the image frame have the dog image or the cat image, etc. Okay, that's how the image classification is works. Okay, so so now we actually understand about Seeedstudio's Xiao series. and we take a look at ESP Shao ESP30 S3 Sense. Okay, you can purchase from the Robu website, and we also take a look at SenseGraph tool, and we actually see the KWS demo and the image classification. Okay, that's about the hardware. We will look into the how we can implement the coming slides. I want to know, like, anyone have any doubts so far, or could you please give me a feedback, like you already understand these things? Please let me know in the comments, chats, or the Q&A. Okay, I don't see anything. If you understand also, you can say, okay, I understand, okay, or good, or something like that. So we need to get some feedback to move on. So that will be perfect. Anyone? Just post like if you understand or something like that. Yep. Agash or someone else, yeah. Okay, I don't see any message, might be some issues, but no worries, we can continue. So how there's a question for Agas, how you can custom models. So that's we are using today. We are using a platform called Edgimbles. Okay, using the Edgimbles. Edgimbles is it's a machine learning development tool. Okay, let me see. There's some issues. Okay, guys. Now I can see the comments. Sorry. Okay, perfect. There are some other questions I can see. Okay. Okay, custom tools and what kind of did algorithm do? Okay, anyway, I'll go through the questions once we complete it. Okay, okay, cool. So we are using a platform called Edgimbles. Okay, we use Edgimbles to create the machine learning data collection, training, and like implementation. Okay, cool. So with Edgimbles, we are able to collect the data, because collecting the data is very important. So image, this is a newborn baby. We need to teach them yes or no command. For that, we need to collect so many yes or no voices, right? So for that, we call collecting the data set. So with Edgimbles, we can collect the data, we can design the machine learning algorithm, and we can test itself, and we can also deploy it to the hardware. So all it can be done with the Edgimbles, and Edgimbles also supported by this Xiao ESP32S3 platform. Perfect. So you can see with Edgimbles, or we can do so many kind of hardware like ultra low power devices like this one, or low end MCU like STM, or high end MCU, or the NPU neural processing unit, or MPU, GPU, etc. We can use anything with the Edgimbles platform. Okay, so I want to showcase some of the community project in the past. Anyway, we can go to the later. Okay, so that's about today and the demo, like the slides, the theoretical slides. Okay, now we are going to make our own voice demo. So let me see if I can run the demo first. We are going to Edgimbles. Okay, first we need to log in. Okay, I already log in. You can see these are my projects. Okay, suppose if I want, I'm going to open here. Okay, this is a public project. Okay, if you can see this is a public project, you will get something like that. This one, let me share it down here also. Okay, let me share it again, so that sorry, let me share it again, then I can see it from here. Okay, just one. Okay, good. So yeah, here you can see this is this is the Edgimbles platform, and the link I shared. What you need to do is you need to clone this project, and you can say like demo. Okay, I'm cloning the project to my profile, and once it's cloned, you can see the project here like that. Okay, actually cloning. I'm just doing the project in a live thing. So yeah, cloning the data. Meanwhile, if it's cloning, I can show you the what's the thing it's have. Okay, when we are creating the machine learning model, it's very important to that we need to collect few data. The data set is very important. Like I mentioned here, we need to collect the data. Okay, first we need to collect the data. We need to collect the yes or no, etc. Okay, so first I'm going to the data acquisition part. We can collect the data in two methods. Okay, two or three methods. One is you can directly connect the device to here and you can collect the data. There is a small SD card slot inside here. So what you can do is you can collect the data here. Let me show you. You can connect the SD card here. You can insert here. Okay. Yep, that's all. So you can actually collect the data to here. Okay, that's one method. Another method is you can already import the data collected from your microphone, your other microphone device like your mobile phone or something like that. Right now we are actually creating a smart light. Smart light means it can turn or turn off the light using your voice. Yes. Okay, like this one. No. Okay, cool. Let me open the demo. Yeah, here. Okay, can collect the import the data and everything. So right now what I'm doing is like I want to delete few data set here. Like I want to like hello and yeah, I want to, let's say if I want to delete the data set. For the data set I'm just deleting. Okay, suppose like okay, so another method we can collect the data is like we can go here and go to the devices, and here we can actually connect the devices. I'm actually connecting my computer here. You can see access to microphone, and I can give a label like on. Okay, this is my label. So you need to label the data. So like the same method. Remember the analogy. You have a kid. This is your this is a newborn baby. Okay, you need to teach the command yes or no. So in order to say yes or no, you need to mention that a yes, right? Or if it's a cat or dog, you need to mention that's a cat, that's a dog into your baby, right? Similar to that, we need to name it the action. So that's called data labeling. So I'm labeling on, then I am saying yes or on, or I can say yes. I say like yes, 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 yes. So that means we are actually recording the data. Let's see if the data will be here. If you go to the data acquisition, we can see if the data here or not. Yes, you can see today, like 1855, I collected a 5 second of data. Let's say if we can play it. Yes, 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 yes. So you can see like we got like a 4 data set, right? So since if you look into the graph also, you can see where the yes part is there. Okay, that's we are doing. The computer will be analyze these frequency, the waves, and try to see if there is any patterns. Same method we can do for no. Okay, we are making no, set label and say no, 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 no. Okay, let's see. It actually collected no. Let's see. No, 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 no. Can see some no and yes, and we can see other past data set. No, no. Okay. So what we are next we are doing, you can see there is a 1, 2, 3, 4 noise there. So we need to split the data to make it as a 1 second, because we don't need any noise data here. We only need the sorry, we only need the data we are actually meant to need it. So I am splitting. So let's see if we'll get a 4 data set right now, right? 1 second, 1 second, 1 second, 1 second. You can see these are 4 data set we have. No. Okay, cool. Here also the yes also we are going to split. So first we collect the data, then we split the data. Okay, splitting is very important, since there are some, you can see there are some noises in the past. Okay, in the previous data. I'm also going to delete the old data label called Robu, since we are only doing yes or no today. You can also do multiple commands like you can also do your own language, like in Hindi or like Marathi or the language you are familiar with. You can also do that. You can make custom keywords. Okay, so perfect. Now we only have the yes or no data set. If you go here, we can see yes or no, and noises also. We need to differentiate if it's a noise or not. Okay, perfect. Now we go to data set. Now we open, if you open, you can see this is a yes, this is a no. Okay, can see the data set, the wavelength you can see. You can, if you look into some like a long time, you can understand that there is a small difference between yes and no, right? Yes and no, you can see small differences. So what we are doing is with the computer itself try to recognize the patterns. Okay, for that we are actually going to create the machine learning model. For that, we need to go to the create impulse. Okay. For the impulse, I'm going to delete everything right now. Okay. For now, we actually collect the data, the yes, no data we collected. Okay. And next, we are going to create the machine learning model. Okay. It's mentioned here. We are actually going to creating the design the digital signal processing or the machine learning blocks. Okay, so here actually the beauty of edge impulse. Okay, so when you're working with Arduino, like the thing about Arduino is you don't need to understand everything about the microcontroller. Suppose you are working about in the Arduino Uno that use 80 mega 3280 microcontroller, right? That's 8-bit microcontroller. Okay, you don't need to understand every single bits or the bit depth or anything. You don't need to understand when you are working with Arduino. Okay, same for the when you're working with edge impulse, you don't need to understand any complex stuff. You can learn later. If you know that, that is beneficial, but if you don't know that also, you can continue the machine learning models. Okay, here I'll explain. First part is we are actually creating the machine learning model. Okay, the first part is we need to mention the input data. Okay, here is the time series data we are actually giving the input data. Input data is the audio, and the size of the data is 100,000 millisecond, that is 1 second, and the window increases every 1 second. It will be the data will be hopped to another 1,000 second, sorry, 1,000 millisecond. The frequency of data is 1,000, like 16,000. It's actually get from the data here to automatically capture from here, from the itself. It actually see, you can see this is the like time, and this is will be the like a frequency, like how much it can do, the power actually here. Okay, cool. And here next one is we need to create a processing block. From here we are actually using what kind of algorithm we are using. Okay, so like there are so many different kind of algorithm called MFCC, MFE, spectrogram, and different kind of thing. We can also use a raw data also. But here, like in the edge impulse, they will suggest, okay, which is most suitable for the our data. So here you can see MFCC, extracted features from audio signals using male frequency septal coefficient, and this is great for human voices. So, and another one is called MFE, male filter bank energy features. So here it's great for non-voice audio. Okay, obviously we are using human voice, so we can use this one. That's all. Okay. Next one is we need to create a learning block. Okay. Here we are actually using, there are different kind of method like transfer learning, anomaly detection, or classification, different one thing, regression. Okay. But here we are actually trying to learn the pattern from the yes or no voice and do the suggestion. Okay. For that we are actually going to make ad. Cool. We are less time right now. Make it fast. Now you can see we select the ODMFCC. We made the classification and we got the output as no, noise, yes. So suppose we put the data into the time series database and it will process with the MFCC, then do the classification and it will conclude if it's a no or yes or like whatever it is. Okay. Another part is we are going to MFCC. Now we need to design the MFCC, male frequency septal coefficient. It's an algorithm. Okay, you don't need to let you know deep about that, but that's good. Okay, here you can see different kind of parameters have the the male frequency septal have different kind of parameters. It's called hyperparameter, like a number of coefficient, frame length, frame stride, FFT, the Fourier fast to Fourier transform. You might already familiar with different kind of things. So we can play with it also to make the model more efficient. But currently we don't need to touch anything. We just going with the default, and we need to click. Save parameter. Then we need to go with the generate features. Okay. Once you did the generate feature, it actually generate the feature using like the no and the yes noise and etc. It actually plot a graph and it mention where is the no will be go, where is the yes will be go, where is the noise will be go, etc. Okay, so that actually what actually happening here. It's very useful to see. Suppose the no will become here inside the noise. It's very difficult to differentiate. Okay. Then at last we go to the classifier. The classifier is the machine learning part. Here when we click here, it actually do the training and it actually generate algorithm. Let me see, go and create a save impulse. Then I go here and create save parameter and I am going to click generate features. So it will do the thing. So about the edge impulse is you don't need to have a powerful computer in your possession. Okay, you can use edge impulse computing power. You can do the training and everything from the edge impulse side. You don't need to have a powerful computer or anything like that. Edge impulse take care of that. Okay. Now we are doing the generate feature part. To do the feature generation. Okay, cool. And we are using all the documentation. We are actually using, there is a thing called a TinyML workshop. You can see here. I'm also sharing this also in the comment box. In future, when you purchase the board from Robu website, you can in yourself you can follow the guide and you can go step by step and see all the experiments. Okay. I'm closing this window right now and yep, it's still running. It's doing the feature extraction. It's actually extracting the features. It's seeing what are the difference between the like yes or no or these voices. Still running. Okay, it's fine. We can go here. We can see what the feature is already extracted here. We can see here. Okay, and the last part is the classification. Classifier is actually, this is the neural network. Okay, this is a neural network we are actually here. Some of you already might familiar with the neural network, so you can see how the neural network is stacks on. So if you are new to neural network, don't worry, you can just go with the default settings. Okay, you don't need to move anything or anything like that. So you can just click training, then the machine learning model will be start training. Okay, after that sorry, after that you can see there's a thing called confusion metrics. Confusion metrics is the metrics that we actually measure machine learning model accuracy. That's where we are actually measuring the machine learning quality. Here you can see it actually see the no is predicted 100% as a no, and that's cool. So that's a F1 score is 1, and the noise is also 100%, and the yes also 100%. Suppose if you look in here, yeah, here is also it's now completed. You can see the no part here, the noise part here, yes part here. So it means the computer is successfully able to differentiate the yes or no or the noise part. The computer is able to successfully differentiate. That means if we have a voice, if we try to put somewhere in the graph, if it's here, the computer will see, okay, that's a noise because we plotted data there. If we put the data here, the computer say, okay, that's a no. Okay, no keyword. Okay, cool. Awesome. So here you can see another one, like after the training also we get something like that, this one. So that's all about you are making your own model. Once you've done the impulse part, MFC part, classification, can go to the deployment. And you can, since we are working with Arduino, you can go to the Arduino and click build. Okay, that's all. It actually create an Arduino library that you can work with the Arduino IDE. Okay, it will take some time to create the Arduino building model. Let's wait. Meanwhile, we are waiting. We can see and check how it will be look like a computer vision model. Like suppose a cat and dog, how it will be look like. So if I'm going to cat and dog and see, it's now working. Okay, to take some time. So all steps actually mentioned here. If you go here, you can see. Yep, it's done. Once it's done, you can see a library is downloaded. You can see a library is added here. Okay, awesome. So what we are going to do is now we open our Arduino IDE and we need to install the board manager ESP32 and we need to check select access Xiao ESP32S3 board. This is very important. Then we can go sketch, include library and add as a zip library. The library we already downloaded, right? Library already here. Here the downloads. Okay. So we need to open it. Okay, let's see. Demo. Okay, library installed. That perfect. So once the library installed, you can go to here. You can see the library will be here. Suppose this is the library we are using. Okay. Now we can go to the example and the library. Once we add the library, you can go here and you can go to the examples. The example that I mentioned, the code and everything will be already documented. Okay. You can go here and click here. Okay, click here and we will paste the code here. Okay, make sure that your header file will be the same. Okay, that's only you need to change. That will be fine here. You need to compile it. It will take bit time. Okay, you need to compile it. It will take some time to compile. That's all. And please wait few minutes to complete the compilation process. Once it's done, you can actually connect it to your examples, like connect it to your Xiao series, Xiao ESP3. They plug it here, then you can see the output. Let's see. Once it's compiled, we need to upload it. Okay, it's doing its magic. Let's see. Let's see. It's compiling. It will take some time. Meanwhile, I can go to the question and answer. Let me go and. Okay, there is a Q&A. It would be great if you provide a recording after. Okay, sure. And there'll be a chat. Let's see. Need to make it big. Okay. Okay, it's like it mentioning it does not have a thermal throttling issues like Pi 3 or Pi 4. So there will be thermal throttling a little bit. You need to like compensate because it's all running on the ESP3 here. So you need to do some kind of a what we call a heat sink or something like that. Just need a passive heat sink or something like that. But it depends on your application. But when I check myself, I don't see that much thermal throttling using the image detection or something like that. Okay, another one is like supposedly we want to create a self-learning hearing aid that applies equalize setting at first training on frequencies of 15. If you can even apply the application graph for you. Yeah, like that also can be done. Like it depends on the frequency with that frequency power profile. You can implement the project that he may actually mentioned. Okay, there is a mention like you upload all the data to Edgeimble. Is it contracting the original advantage of the you mentioned? The thing about like we actually uploading all the data to the cloud. That actually true, but that only the training data. Okay, we can use the training data without the person information. But once we train that, upload the training data, it use the actual real world data like customer data. That data is not that send it to the cloud. You got the idea, right? You don't need to send the customer data or the person data to the cloud, but you can use some kind of dummy data to train the machine learning models. So that actually the privacy part. Now it's actually compiled perfectly. Now I'm connecting to my board and make sure that I am on the correct port. I'm uploading the code. Okay, let's see. Okay, now we have another question. Can we also train model image this platform? Yes, we can. We can train images. We can do another kind of sensors like gas sensor, like a radio sensor, etc. We can also do that also. I'll show you the example after this demo. We have one more demo that actually detect whether if it's a apple or banana. Okay, meanwhile it's uploading, you can also share your questions, okay, in the chat box. If I missed anything, you can share again. Okay, if it's download uploaded the data, now I'm going to run it. Okay, now you can see in the screen. It's mentioned it's a noise. You can see the confidence level. Okay, noise is equal to 99. That means 99% it see it's a noise. If I say like yes, yes, you can see 80% is confident that a yes. You can see the LED is also turned on. Yes. Yes. Okay, the LED is turned on right now. If I say like yes, if I say no, no, LED is turned off. That's perfect, right? All everything is done on inside the microcontroller. Perfect. Same way we can do. I want to show you another demo. We are running out of time. I can show you another demo. Let's see. Here, okay, this is another thing. I'll show you later. We have another demo which can actually which actually use uh, computer vision, basically image recognition. Let's see if it can run. Yeah. So suppose I have a Apple image here. I'm showcasing to the camera and see. So you can see if it's an apple. You can see the bottom of Arduino ID here. See, it's an apple. It's measuring it's an apple. So detecting the apple and it's printing. So we can make a smart scales. You know, when you can make a prototype that work with a supermarket where people don't need to wait for the vegetable to get labeled. So you can make your own custom application. Suppose if I'm taking banana, let's see it can take banana. You can see the result here. Okay, here will be the result. Let me see. Where is the banana? Okay. Let's see. Yeah, it's give it some time to recognize it because the light and everything. Yeah, perfect. Now it can see it detect it is a banana. That's why it's printing. If it's a banana, it's printing. Perfect, right? So this is an example of computer vision. Okay, cool. Now I know it's not, I don't went to the deeply, but I give an overview about how TinyML can be done with these small devices. It's only cost like 1,400 rupees or 1,500 rupees only. And this comes with all the camera, microphone and everything. And then let's see, like I can also show another demo. If you want to stream images from itself, we already added I already uploaded a program inside the program inside the module and see if we can run it. Okay, cool. Can see if I set start stream, can see started streaming. Okay, the light is very less here, so I can actually, there are so many options inbuilt here. You can inbuilt increase so many kind of things here. Color bar here, we can we can check the facial recognition. Let me turn on my light so it can see better. Things too dark here somehow. Okay, yeah, this also run, it's all running on inside this tiny device. You can do a lot of stuffs here. You can flip the camera and you can do onboard like face recognitions and face detection, different kind of things here. And you can also get still also like if I take some photos, I can save the photos inside my computer. Here you can see, you can take for further labeling or something that you can do that. Okay, cool. I want to show the capabilities, and somebody already mentioned how we can do the computer vision, right? For that, I can show you the cat and dog demo. Yeah, here. The same method we did images. We capture the sound, right? We use a microphone, right? Same method we can also capture images. Okay, so right now it can do because I'm already using the camera, that's why I can do that right now. But it actually we can use our web camera also to capture the images. Once we capture images, we can go to data acquisition, we can see the images here in the right side. In the past we saw like in the data acquisition part we saw like the waves, the sound waves. Okay, but in the images we can see the images, like if it's a cat etc, we can label it, and we can use impulse. Instead of we here we are using transfer learning. Okay, if you click here you can see it automatically suggests if it's an image and you want to do transfer learning on or something like that. Okay, and if you are more advanced, if you want to use your own Keras machine learning models or something like that, you can actually do that in the classifier part. You can do, and you can go to the switch Keras export mode. You can run your own architecture. You can create your own neural network architecture inside. Okay, so that's all about our small workshop. So the next step is you can go and purchase Xiao SPS3 from Robu for like 1,499 rupees. For the cost, you will get an onboard camera, onboard microphone, and all the examples and documentation is available, so you can easily get started.